Okay, so today we are going to solve the problem ransom query 2D immutable. So first let me make this thing clear that in any question of ransom query, if the array is mutable, means the array keeps on changing in some queries, then you cannot solve this problem by just using prefix sum or some pre-computation. For that, we will require some advanced data structure like segment tree. Like there is a question in lead code only. There is some query new table. Yeah. So this question we require segment trees. We cannot use prefix sum here, it will give clearly. So I will also try to make a video on this one. First, let's understand this immutable one. And I have already created a problem on 1D version of this problem. So you can check that out for understanding what basically prefix sum mean. So let's dive into this question. So basically we will be given a 2D matrix and there will be some queries where we will given the upper left corner and the lower right corner, and we need to calculate the sum of all elements inside that rectangle. So let me first explain what this means with some test case like here. Okay, so let me take this one only. Okay, so here this question is, so basically we are given this matrix, and what we need to find is, let also write the index also first so that you can understand. 0, 1, 2, 3, and 4. So first, these 5 are basically the input, means the num matrix that we are creating, and here this is the first query that we are getting. So this 2 means the row number of the upper right corner, and 1 is the column of the upper right corner. So what basically this means, we'll go to the second row, this one, and first column. So this point, this corner, okay. And from where, what is the lower corner? The row of the lower corner is 4, and the column for the lower corner is 3. So we'll basically go to the row number 4 and column number 3, this, that is this corner. So this red box here, it is already marked. So we basically need to find the sum of all the element in this box. So what will be that? 2 plus 0 is 2, 2 plus 1 3, 3 plus 1 4, plus 1 5, 5 plus 3 8. So we can see also that the output here is 8. Similarly, if you want to see one more example, here you can see 1, 1, 2. You can try it out by yourself. You will get more understanding about the problem. So, what approach comes to our mind first after seeing this question? That we are given the row and column of the upper right, upper left corner, and we are given the row and column of the lower right corner. So one basic approach, or we can say the brute force approach that comes to our mind first, is basically looking from this row. Means in this row we will look from for all the columns till here. Then we will go to this row and again loop till here, and we will maintain a variable obviously to calculate the sum, and then again move to this row and calculate the sum till here. So this one will be the brute force approach, and the time complexity for this one will be obviously big of m into n, because we are, for in the worst case obviously, we are traversing the whole array. So let me just show the code for the. It is easy, but I will still show you the code. Basically, there's no need to create this one also. You can obviously do this in the matrix array directly also. So I'm basically assigning the matrix array to the prefix, and after that, what I am doing in the brute force is basically I am here maintaining a sum variable, calculate the sum, and I am looping from this row that we saw here. I will start from, let me first clear this one. So what we are basically doing is basically we will start from this second row and loop till the last row where till where we need to find, like from 2 to 4 we need to find. This is 2, this is 3, and this is 4. We will create a loop for that one, that is this loop is doing for int I equal to row 1 to I less than equal to row 2, and then we will go from column 1 to column 2 in for each row. For each row, this j variable will move from this column to this column, then this. So, and we will keep on adding that number, and after that we will return this sum. So let me just quickly run it and show you. So you can see obviously it is giving this answer correct for this smaller values, but if I submit it, it will give clearly I have already done that. Yeah, you can see that I have got TLE for this one. So yeah. So now let's think what optimization we can do. If you have already watched my previous video, then you can think of one optimization obviously, that is for each row we are looping from this column to this column. Then again for this row we are looping from this column to this column. So you can think of this array, or let's say this one, as a 1D array, and create a prefix sum for this all. Means what I'm saying is basically create a prefix sum for every row, so that when we loop in every row we will not need to go for go and iterate through each column to get the sum. We can get the sum in big of 1 by just using prefix sum that I have already told how to do that. Means if you want sum from L to R, you can do prefix of R minus prefix of L minus 1. So that part you can, if you don't know how to do that, you can watch my previous video. There I have explained. So yeah, let's look into the code of second approach. So first we need to obviously create this prefix array. So what I'm doing is and I'm initializing variable, initializing this prefix vector with all zeros. So what I'm doing is basically looping in every row and every column, and then after that I am creating this prefix array. So this, let me just show you what this prefix array will contain. Then is for every row, let me take Therefore, for every row, we will iterate. Yeah. So for this row, we will iterate through every column and create the prefix array that is, let me write this one. Value. So what basically this one will contain is 3. 3 plus 0 will always remain 3, then 4, then 8, and then 10. For this one, this will contain this, and for second row, it will be 5, 11, 14, 16, and 17. And similarly, you can think what will happen for each row. So that's what we are doing over here for prefix of ij. If j is 0 means if you are in the first column, then obviously it will contain the first element only. And for next one, we are basically adding the previous previous el- prefix element to the matrix of ij. You can I've already explained this how to do this. So you can watch that. After building the prefix array for the query related problem, what we can do is for this one. Yes. So what I'm basically doing over here is I've obviously created a sum equal to 0, and the main thing optimization that basically happened over here is now we only need to iterate in each row, but in the previous approach we are iterating on each row and each column also, but here we need to iterate on only a row, and for each row this sum variable will calculate the means for each. Let me explain this. When we are iterating on this row, instead of going to sorry, for this row, what instead of going to each column, what we are basically doing is we have already created this prefix sum array, and we will get the sum till for this one in just big O of 1. How? We will find the prefix sum of this index and minus it with prefix sum of this index. So what that is 4. So that is basically 4 minus 1, that is 3. So we got the sum for this one, okay, 201. And similarly for this one, what we will do is basically 6 is the prefix sum till this index, and minus it will minus that with the previous one. So that will be 6 minus 5, 6 minus 4, sorry. Again, you can also verify that sum of this element is 2, and for this one the sum should come 3, and let's check. So we will do 4 minus 1, that will give us 3. So basically what we are doing is for each row we are just calculating it by prefix of that column 2 minus prefix of column 1 minus 1, means the previous one of the first column. Let me explain also that what we are doing is basically taking the prefix sum till this one and minusing with the previous one. So this will give us the sum till this range. I hope you understood that. Here, yeah, if the column one is 0, means what this means is if you are finding the sum from here to here, then obviously there is no column minus 1 in this side. So we basically return the sum till this index, that is prefix of column 2. So that's why I have written if column 1 is 0, then it will just give prefix I of column 2, and if it is some other column like 1, 2 or 3, then it will do take the sum of first prefix I of column 2, that is the sum till here in the prefix array, and then minus it with the prefix I of column 1 minus I minus column 1 minus 1. That is, this is our column 1 prefix sum till here will get subtracted, and that will give us the sum till this one. I have explained it many times. So let's just run this code with me. This- yeah. So this code should work, and it will also get submitted. I have already yeah. So you can see I have already submitted this code, and this will get submitted, but we can also optimize this further. Like here in the question, you can see that it is told that the sum region query should work on big of one time complexity, but for this question, our sum region query is taking big of n time because we are looking through each column. So how we can optimize this further? I've already explained the prefix sum concept. Okay, so now we are going to discuss the most optimal approach for this question. So basically, we need to answer all the sum region query in big of one time complexity, but the the two approach that I discussed earlier were of big of m into one n, that was the brute force approach, and another one was better approach, that is big of n, because we were traversing on all the rows. So now for this answering this query in big of 1, what basically we are going to do is build a prefix 2d array. So let me explain what this prefix 2d array means. Yeah, so you can see the prefix 2d array means the sum from the top left corner to I comma j rectangle. Let me explain you. Suppose this is our I comma j, this point. Okay, so basically what this prefix array will contain is basically sum from the top left corner to I comma j, all the element that are inside this rectangle, the sum of this all element will be added over here at this point. Let check also that whether it is true or not. 3 plus 1 4, 4 plus 4 8, 13, 19, 22, 24, 25, 27, 28, 32, 33, 34. So you can see that our prefix sum array also contains 34 over here, and I will explain why I have written all this 0 over here. But let's right now just focus on this part. You can see for I comma j, this rectangle, it contains the sum till, means the sum of all element is in this rectangle. Okay, or if you want to see one more example, let me show you a smaller one. Like suppose I comma j is still here, so it will contain the sum of all the element in this rectangle. That will be nothing but 4, 9, 15, and 18. Yeah, so you can see our array is also containing 18 till here. So I hope you understood what basically this prefix 2D array means. But the main question is how we are going to build this array. So for building this array, we are going to use this formula over here. Prefix of I comma j means ij will be built by adding the element at that index I comma j with the prefix of I minus 1 j means the previous row and prefix till previous column and this one. Okay, let me explain it with drawing rectangles, then you will understand it better. And here is this should not be plus, but it should be minus. Okay, yeah. So let me explain this real quick. So what basically prefix I comma j means is adding this. Suppose this is our ij. Okay, this one. So we will add this element I comma j, that is 1. Okay, and we will take the sum till prefix I minus 1 j means the previous row. Let me draw rectangle. So what we want to find is sum till here, and for finding that, what we are basically going to do is first we will add the sum till this previous row. Means the prefix of I minus 1 j will contain the sum of all the element in this orange rectangle. So we will get the sum of all this element, but we also want the sum of this element also, right? Because these are present in the yellow rectangle. For that, what we are basically going to do is prefix I of j minus 1. So that will be nothing but the sum till previous column. Let me draw the rectangle, then you will understand. What basically this prefix I j minus 1 means is basically sum till this range. Okay. Here, but here I think you notice there is one problem, that is this all element are getting counted twice. So for that we are basically doing minus prefix I minus 1 j minus 1. Prefix I minus 1 j minus 1 is nothing but eh, this one. So that's why we are basically doing minus, so that this the we have counted it twice, so it will get nullified and it will give us the correct sum. Let's also check this. What is the element at this I comma j? That is 1. Okay, and the sum till prefix I minus 1 j is nothing but 28. Okay, and the sum till for this green rectangle will be 26, and the sum of this blue rectangle will be 21. So let's just calculate this real quick. 29 plus 26 will be nothing but 55. 55 minus 21 will be 34. So you can take that it is 34 over here. So I hope you understood how to build this prefix array. But now let me explain also why we are doing this zeros over here. Because suppose when we are at this index, there is no I minus 1 and j minus 1 over here. Basically, the prefix array will contain only 3. So for that, we will have to write so many if and else. Like I can show you the code. I have written that. Yeah. So basically, for building the prefix array in that way, means if we take only the sum of, means only the prefix array till 0 to n and not this one, we will have to write so many if and else condition. Yeah, this one, this code, we have to write many if and else condition. Yeah, you can do that in that way also, but there's an easier way. That is, we will create n plus 1 an m plus 1 size array and first initialize this all with 0, and after that we will use our formula, that is matrix I comma j, and this one. Why we are doing I minus 1 j minus 1 over here? Because we are obviously we are starting from index 1, but we want the sum of index number 0. I hope you understood what basically this means. So basically we the main idea behind why we are creating n plus 1 and m plus 1 size array is so that we don't have to write so many if and else condition. Because when suppose you are at this row, there is no this column, there is no j minus 1 over here, so you will have to write if else condition for that one also. Suppose you are at this row, then you will also have to write condition if else, because there is no I minus 1 over here. That's why we are basically maintaining this zeros over here, so it should not affect our sum also, and we can easily write the formula. Okay, so this was the part of building the prefix array, but now comes the main question is how we are going to answer the query. Means how we can find the sum of some range, because we are not told to find the sum from this to this rectangle or something like that. We will be given any rectangle, like suppose this one. So how to find that one? So for that, what we are going to do is first basically prefix of row to column 2. What this means is, I will show you one example over here. Let's take this one. Okay, 2143. 2143. So basically 2 is our, I've written the indexes. So this is our row 1 and column 1 means this is our the top left corner, and 4 3. So this is our the right down right corner, and we want the sum of this rectangle over here. Okay, so how we can do that? First we will take the sum of row to column 2, means sum till over here, this one. Okay, okay, so this orange rectangle is basically containing the sum of prefix row to column 2, means the sum from the top left corner to the row to column 2 rectangle. But in this rectangle we are getting this all element also, but we don't want that, because we want the sum of only this blue rectangle. So we need to remove this part. So how we can do that? We will subtract minus p prefix of row to column 1 minus 1. So what basically this means is, we will go till row 2 and column 1 minus 1, means this is nothing but this rectangle over here. I hope you can see that this green part, it is, we are subtracting this all element over here. Okay, but we also want to subtract this part also. So how we can do that is by subtracting minus prefix row 1 minus 1 and column 2. So this part is nothing but we will go till row 1 and column 2. So that is this part. Let me take some other color. Yeah. So this is prefix of row 1 minus 1 and column 2. But here you can see one problem, that we are subtracting this part, this 3 and 5 two times. Okay. So for that part only we are just adding it again, prefix of row 1 minus 1 and column 1 minus 1, that is this part, means this rectangle. Let me show you. So the color, yeah. So this part, okay, 3 and 5, this part we are adding it again because we are subtracting it two times. So to make it one time only, we are adding it from by after doing this query completely, we will get the sum of all the elements in this blue rectangle. If you want, we can also check this quickly with an example. Like, we wanted the sum of all the elements in this rectangle, right? Let me increase the font. Okay, 2 1, and what was that? 2 1 4 3. Okay, so for that we are basically doing sum till prefix row to column 2, means the prefix sum over here, and that is nothing but 38. So we will get 38. Okay, and then we are subtracting prefix row to column 1 minus 1, means sum over till here, that is 14. We are subtracting 14 over here, and then we want prefix row 1 minus 1 and column 2. It means the sum till this portion, that is nothing but 24. So we will add that 24 over here, plus 24, and then we are, sorry, minus 24, and then we are again adding the element till this part, that is 8. Let me just quickly calculate this and check whether our sum is getting correct or not. So it is coming out to be 8, means this whole portion after solving is coming out to be 8. Let us also verify this. The sum of all the element in this blue rectangle will be 2 plus 1 3 plus 1 4 plus 1 5 plus 3 8. So yeah, this is working fine. Just one check in the code that we will maintain is, you can do either create the array till, basically what I am saying is, you can create prefix array of size 1 greater and do that, but I am doing it in this way. Or you can create n plus 1 size vector, and so it will basically contain this 0, and we won't have to write so many if else condition, because when we will be at this I comma 0 and j comma 0 part, there is no I minus 1 or j minus 1. So if we do it, it will give segmentation fault. For that, we are basically creating a one size bigger array so that it will contain 0, and we can do I minus 1 j minus 1 easily without writing so much of if else. But I have done with it if else condition only. And if we are at first row, then there is no column above, means we cannot do j minus 1. So we'll simply just build the prefix sum of 1D array, means like for this part we'll just do 1D array like we were doing for 1D part, only that how we will do it. And for this row or column also we will do it in how we are doing it in 1D part. That's what I have written. If I is 0 and j is 0, just simply copy that element. And if row is 0, first row, then use prefix 1D array formula. And if column is 0, then also prefix 1D array formula. And if it is not neither row 0 or column 0, then we can use our formula that we have written over here, I j pi minus 1 j. And to answer the query, we were simply doing then again we need to check if it is row 1 column 1, then we need to just return the miss. If it is asking the sum till over, just till over here. Okay, so obviously this is just this element 3, and suppose it is asking the sum of this part. Okay, means row is 0, so we can just return this using prefix 1d formula. That's what I am doing. Means if row is 0, then use prefix 1d formula. Similarly for column 0. Or if you do it n plus 1, then you don't have to write so much of this if and else. You can simply just write this return formula and it will work fine. So yeah, and this is nothing but the formula that we have discussed over here, and we can submit it. I mean, I'm just showing it by running. I've already submitted it. Yeah, so it getting accepted. And for submission part, I think I have not done it. Let me just do it and show you. This should get submitted. Yeah. So that's it for this video. See you in the next one.